Good morning, good afternoon, and good evening. I'm Nick Hodges, the Director of Product Management at Embarcadero, and I'm here to talk to you today about connascence, or how to measure coupling. You've heard me and many others say that tight coupling is bad, and I think we'd all agree on that. But what exactly is tight coupling? How do you measure it? How do you know when something's coupled together? How do you define that? How do we create a taxonomy of coupling that will enable us to know exactly how we can solve the problem of tight coupling? Well, that's what connascence is and what it does. We measure coupling by the notion of connascence. Connascence is a software quality metric and a taxonomy that measures coupling and the different types of coupling. So two things are said to be connascent when they must change together for the system to remain correct. That is, if A changes, then B has to change as a result of A changing. Those two things, A and B, are then said to be connascent or to have connascence. When two things are coupled together via connascence, we should always refactor from a higher degree of locality and strength to a lower one. The notion of connascence was actually first proposed in 1996 by Melior Page Jones in a book called What Every Programmer Should Know About Object-Oriented Design. In it, he outlines this taxonomy of connascence and describes how it can measure your coupling and help you improve your coupling by reducing it. Connascence is said to have three axes or measurements of connascence. First is a strength. Stronger connascences are harder to discover and harder to refactor. Something that is very, very difficult to see, some coupling that's difficult to find, is said to be strong. The degree of connascence is an entity that has thousands of other entities that it's connected to is definitely more complex than one that has only a few things that are connected together. So the more modules, the more code involved with a particular coupling is said to have a strong degree of connascence. And finally, there's the notion of locality. Connascence inside of a routine is said to have local connascence, and when two modules that are completely separate, say a DLL and an executable, are connascent, they are said to have distant connascence. Local connascence is preferred over distant connascence. So here is the list of connascence types in ascending order of complexity. 5 of them are considered static. That is, Kinesins of Name, Kinesins of Type, Kinesins of Meaning, and Kinesins of Position, and Kinesins of Algorithm. By static, I mean that these types of connascences can be discovered at design time. You can read your code and find out that you can see that you have coupled yourself in these different ways. Next come dynamic connascences. These are those that are only observable at runtime. They are the Kinesins of Execution, Kinesins of Timing, Kinesins of Value, and Kinesins of Identity. These are the 9 types of connascence originally proposed by Page Jones in his book. And at the end here, I'm going to propose a 10th type of connascence called Kinesins of Creation. And I'm going to propose that as a new type of connascence that should be added to the taxonomy. The first type of connascence we'll discuss is the Kinesins of Name. And this occurs when components must agree on the name of an entity. This is the most basic form of connascence, and it's perfectly acceptable to have this type of coupling. Again, you want your code loosely coupled, not completely coupled. If your code were completely coupled, then it wouldn't be able to do anything. So we want to keep the level of connascence as low as possible, and Kinesins of Name is the lowest level of connascence that you can have. So here's an example with a procedure called make a pizza and another procedure called prepare dinner that says make a salad and make a pizza. Now, if you want to change the name of make a pizza, the procedure name, for whatever reason, make a pepperoni pizza, for instance, then you would have to go and change that name in the prepare dinner method as well. So those two items are coupled together by the Kinesins of Name. The next level of complexity in Connascence is Kinesins of Type. Kinesins of Type occurs when multiple components must agree on the type of an entity. And again, this is a kind of Kinesins or coupling that's desirable and unavoidable. For example, here is a type called T lettuce type that describes different types of lettuce. And then in order to make a salad, you have to pass in a T lettuce type. So when you want to make a dinner, you can make a salad with romaine lettuce. But for instance, if you wanted to change it to a bean salad, you would have to change the type of lettuce. In other words, make a dinner and make salad is coupled to the type T lettuce type. And this is called Kinesins of Type. The next type of Kinesins after Kinesins of Type is Kinesins of Meaning. And this is a little less desirable than the previous two. And Kinesins of Meaning occurs when multiple components must agree on the meaning of a particular value or values. So for instance, in this example, we have a function called getWidgetType that takes a T-widget. Now, here we have an if statement that says if the status is working, then result is 1. And if the status is broken, then result is 2. So this Kinesins here requires us to have the same meaning for the word for the status type of a hard-coded value, or in this case, a string. Here's another example. If we merely say product.price equals or gets $34.99, that doesn't quite convey the meaning of what $34.99 is. Instead, we might refactor this to create a class called TeamMoney that carries along with it the type of the money, the currency type of the money represented by $34.99. That thus gives meaning to $34.99 and defines what it means, thus reducing the Kinesins of Meaning down to Kinesins of Type, where that's an example of reducing the Kinesins or reducing the coupling of your code. The next type of Kinesins is Kinesins of Position. And this again is slightly more complex than the Kinesinses we've seen previously. Kinesins of Position occurs when multiple entities must agree on the order of values. And the classic example here, of course, is something along the lines of this, where you have a number of parameters passed through the addUser method, and they have to be in the correct order, otherwise the function will not work properly. For instance, you have to make sure that first name is first and last name is second in this method. A way that you might refactor away from that is to create a parameter record, a record that holds all the parameters, and then you can simply pass that an instance of that record to addUser, simplifying the code and reducing the need for things to be done in the proper order or position. Thus, you can refactor away Kinesins of Position down to Kinesins of Type. The final type of static Kinesins is the Kinesins of Algorithm. And this is simply the case where two components must agree on the same algorithm. And this is a very simple thing to think of. For instance, two modules might need to communicate with each other via a TCP stream or some other method of communication. And if you want to make sure that the two modules can communicate via encryption, both of those modules need to accept and use the same encryption algorithm, the exact same one. If one algorithm changes, obviously the algorithm is going to have to change on the other side. So that's Kinesins of Algorithm. And again, this is a more complex, difficult to deal with level of Kinesins than the ones we've seen previously. It's also the last one that can be discovered at design time by examining your code statically. The first of the dynamic types of Kinesins is Kinesins of Execution. This occurs when the execution, the order of execution of multiple components is important and makes a difference. For instance, here's a user record that takes a first name, a last name, and age. Then it adds the user record to the user manager and then sets the birthday of the user. Obviously, the order of execution here is important, and we must change the birthday to be executed before the add user call if we want the birthday to be included in the addition of the user record. Here's another example that's a little trickier to understand and at design time by code examination, and can really only be understood when the code is executed. And that is, you've got a sprocket processor that adds some sprocket and then validates the sprockets. Well, should you validate the sprocket before it's added or after it's added? That's a question only you can answer by running your code or by knowing your code base. But it's an example of Kinesins of Execution. The next type of dynamic kinesins is Kinesins of Timing. Kinesins of Timing occurs when the timing of the execution of multiple components is important. Classic example here, of course, is a race condition between threads, where the timing can change as a result of different threads being created and executed at different times, and thus the threads race towards a particular resource or value in order to read it or write it. This occurs because of Kinesins of Timing, and this can be very difficult to find and refactor. Thus, it's one of the highest forms of kinesins. Kinesins of Value is the next most complex form of kinesins, and this can be very difficult to discover as well. Kinesins of Value occurs when several values must change together. Here we have a unit test that checks to us the value of the balance of a price scanner after frosted sugar bombs has been scanned, and it's set to 50 cents, $50, whatever. And that value must be known at both the test checkout value and the price scanner value. In other words, that value must change in the test if it changes in the scan function. A better way to do this would be to include the item and the price together in the price scanner scan method, so that when you write the test, you can keep the value in a single location, thus reducing the locality of the kinesins and reducing Kinesins of Value down to Kinesins of Position or Kinesins of Name. And finally, the most difficult to discover and refactor type of kinesins in Page-Jones taxonomy is Kinesins of Identity. This occurs when multiple components must reference the same entity. Classic example of this is a sales report and an inventory report that have to use the same customer data module. If the customer data module is changed or the sales report needs to use different data than the inventory report, you've now got a coupling situation where the sales report might reflect one chunk of data and the inventory might reflect another chunk of data if anything in the system changes. Another example would be an output report that couples to a particular spreadsheet. If the spreadsheet changes, the inventory and sales reports would change as well. This is Kinesins of Identity, where modules depend upon each other in ways that are difficult to see and thus are difficult to refactor and difficult to decouple. So those are the 9 types of kinesinses that were originally laid out by Mailer Page-Jones in his book. I'm going to propose a 10th type of kinesins that I call Kinesins of Creation. And this occurs when you create one class within another class. And this is probably what you think of when you, in the modern day here, when you think of coupling. And certainly it's the coupling that I've talked a lot about with regard to dependency injection. Here we have a case where a process sprocket method creates an instance of T-sprocket processor. Here we are dependent and hard-coded to the particular instance of T-sprocket processor. This type of kinesins can be very difficult to break if you don't use dependency injection or other types of refactoring that will remove the coupling to T-sprocket processor. This is nothing official, it's just a type of kinesins that I've proposed that I didn't see in the other 9, and certainly maybe something that didn't occur to Mailer Page Jones when he wrote his original 9 types of kinesinses. Now that we know about kinesins, what can we do about it? Well, the first thing is we should always eschew tight coupling and embrace loose coupling. That should be the goal of writing all of your code. Loosely coupled code is generally easier to test, easier to maintain, and generally easier to deal with. We should use the new vocabulary that we have now of kinesins, although it is 20 years old, to talk about coupling in a proper manner. If you see the coupling of kinesins of type as coupling of type, identify it as such. If you are dealing with kinesins of identity, say, hey, there's an instance of kinesins of identity. So don't be afraid to use your new vocabulary that you learned today. And of course, we should always reduce the kinesis in your code, especially between modules, in order to improve the quality of our code. The locality of kinesins is probably the most difficult one to deal with, and that is when you have 2 separate modules, say 2 packages or 2 DLLs, or in the very difficult case, say a C# REST service that is consumed by a Delphi REST client. If you have kinesins between those 2 things, you're going to have a difficult time decoupling that or reducing the kinesins. So reduce kinesins in your code, especially between modules. And then always refactor to the lowest degree, locality, and strength of kinesins as possible. If you use good coding techniques such as constructor injection, you will very often reduce your kinesins very naturally. And thus the method for refactoring would be to use techniques such as constructor injection to decrease kinesins. Avoid writing coupled code in the first place by keeping kinesins in mind. Keep all the 9 or 10, if you include my proposal, types of kinesins in mind while you code, and you'll write code that's not as coupled as it might be. And finally, if you want to find out more about kinesins, you can go to this URL here, kinesins.io, a website that is a taxonomy of the kinesins and the source of much of my discussion here today. Thank you. I'm Nick Hodges, and I thank you for your attention today. And now it's time for questions.
If there is any questions, go ahead and put them in the question panel in the GoToWebinar software, and we'll make the answer for you. There's a couple of them in here already. One question is, how do generics fit into kinesins?
Well, I don't know if there's any specific or special relationship between generics and kinesins, but you can write heavily coupled generic code just as easily as you can write heavily coupled non-generic code. So I guess generics would fit in and their code would. And about audits, is there some audit for detect code? Marcus, good question, and I'm afraid I don't know the answer to that. I don't know. I do know the RTL has a call you make passing in an interface to see if there is a cyclical reference, and it's pretty good at determining if there is one, but I don't remember what the exact call name is. You might want to look in either sysutils or system unit for that call. I believe that is it. James Woods asked, what is dependency injection? That's a good question. Dependency injection is a $50 word for a 25-cent concept. And basically, dependency injection is the notion that you, instead of creating your dependencies, you inject them into the class. So, for instance, if you have an order processor that requires an order, or say a order database filer, you, instead of going my order database filer.create or tu database order filer.create, you pass an instance of that class into your usually through your constructor, and you end up having less of a dependency on it. You invert the control. Inversion of control is another term that's used there, and you end up deferring the creation of your classes back to the composition root of your application. And so particularly if you pass in interfaces as opposed to class types, you can become more loosely coupled by depending on interfaces instead of concrete implementations. I hope that's a quick and dirty explanation of dependency injection. You can read my book that's coming out on it someday, soon, hopefully. Apparently there's no Dutch word for Connascence. I guess you'll have to use Connascence. Oh well, I don't know how to speak Dutch, so I can't help you there, Mark, but I understand your point.
Actually, I wasn't sure how to pronounce it until I heard you pronounce it, and then I was like, oh, because I was going to say
Connascence.
Yeah, I was going to say consensence, or I don't know. I'm terrible at pronouncing things.
Yeah, it's like a banana. You never know when to stop. Banana.
Yeah, exactly.
But no, Connascence, yeah. I actually didn't know how to pronounce it until I heard a guy named Jim O'Brien give a talk on it, and he said Connascence, so I assume that's the correct way to talk about it. And then Alf is asking any tools around to do such static tests, and I said, yeah, I would say yes, audits and metrics, built right into your IDE. We'll tell you these kinds of things very, very clearly.
Sounds like a topic for another webinar.
Indeed. Indeed.
Excellent. So good, guys. One thing I would like to say just so everybody is we do have the call for papers out for Code Rage.
Yep.
Code Rage is about a month away now. So if there's sessions that you'd like to see, but don't feel comfortable enough to present yourself, do drop myself or Jim an email over. If there's something that you'd like to propose a presentation around, then go to the Jim, have you got a link for the call to papers that we can share out?
Let me put that in the window here.
Okay. There's also another question from Ross. Are there any good unit testing examples? Now I know we have DUnit and XUnit built into the IDE.
Well, yeah, there's DUnit, and we also ship DUnit X, which is a new platform as well, a new framework. But as far as examples of code, good unit testing examples. I have let me see if I can find Delphi unit tests. We started this little project where we started writing unit tests for, how do I put this in?
Just select the question, then you can paste it. So.
Yeah, it's a project we started, Kenneth Cochran actually started it to write some unit tests for the Delphi RTL so that we could sort of have a community of community-built unit tests for the RTL and the compiler and whatnot. So there's some examples of how unit testing might work in that code base that I just put the link to in the chat, which I hope you can see. Well, one more, Rox is asking about with toxicity metrics. How do we know if the values they're seeing are good? I believe the lower the number, the better is generally how that works with toxicity metrics. I'm sorry. And the audits and metrics will tell you very clearly what is good and what is bad. So I would explore audits and metrics in the IDE if you have them.
Well, there's Fix Insight, and then there's another one that was part of the. Well, one comment I was going to add though is that I've been on teams before where later on in the process, after the codes mature or become more mature, they've decided, hey, you know what, we should start looking at audits and metrics and all this stuff. And you turn them on later, and you end up with pages and pages and pages of things that need to be changed, and it's kind of daunting. And so your best bet is if you can start in the beginning, observing, looking at, these code quality indicators and trying to maintain good quality code from the beginning. If you can't, then my recommendation is that as you are making changes to your code, as you're going in and fixing bugs, then that's when you, add unit testing if you haven't done unit testing before. That's when you try and address the code quality issues and refactor to a better quality code and stuff like that. Because otherwise, it can be very daunting task. Yeah, so Marco just posted it's the code toxicity. It's part of Berlin from the Castelia work. That's what I was trying to think of, code toxicity. So there's the audits and metrics and code toxicity.
Yeah.
Code toxicity is in.
Yeah, and Castelia metrics are included. Yeah.
Yeah, and that's in Pro and Up. So that's what I was trying to think of. Thank you, Marco. But yeah, that's a good one there. That's available for everybody. It's not quite as detailed as the audits and metrics, but you can use that in Professional and Up as a way to measure your code. But so anyway, if making your code into smaller units, you have smaller segments of code instead of the one unit to rule them all with all your code in it, makes it easier to maintain. and then just as you go, as you're maintaining your code, as you're fixing bugs, adding features, doing what you can as you go, and that makes it a lot easier to tackle that project.
Bruce McGee just posted Code Healer, Pascal Analyzer, and Fix Insight are also good static code analysis tools, and he's absolutely correct.
Yes, those are great ones. Code Healer, Pascal Analyzer, and Fix Insight.
Yeah, there's a lot of good tools out there for Delphi for code analysis, and I think we don't do that enough. There's a lot to be learned by doing static code analysis, which is actually analyzing your code at design time, at coding time, as opposed to at runtime. And then Ross is saying, well, what about C++ Builder? And I would say there's a ton of static code analysis tools out there for C++.
Yes, that's true. Actually, I'll put a plug in here for Fix Insight. I've used Fix Insight quite a bit, and
yep,
the way
great tool
integrates into your hints and warnings, which you should be paying attention to as well, is very nice.
Yep.
I really like that. It made it very easy to use.
Indeed, it is.
And it's actually a good one because if you are coming in late to you got some existing code base, you go in and say, well, let's just look at this one issue, right? We'll just tell me about this one issue, and then look, and then go through and fix that. Then, okay, tell me about another issue, and you can just turn them on slowly, which makes it easy to roll in.
Very true. So anyway, I hope people learned a little bit about coupling through Kinesins. I was very surprised to find that this had not really been talked about much, despite having been put into a book 20 years ago. So that was kind of fun.
When you mentioned the book where it came from, I'm like, oh my goodness, this has been around a while.
Yeah, it was published in 1996. If I do my math right, that's 20 years.
Yeah.
So, yeah, I do have a chapter on that in my forthcoming book. So most of the material, if you watch the webinar today, will be in that chapter on dependency. The book is on dependency injection. I'll finish it someday, I promise.
It's the last 10%, which takes 90% of the time.
I just got told by David Millington that we have code audits in C++ and Architect, so that's good to know.
I thought we did, yeah.
I apologize. I should know that. I should know all of our products. I'm sorry. Thank you, David.
So Ross is asking, is it coupling or decoupling?
Did I use the word wrong incorrectly? Is that what he means?
I'm not sure.
Well, you want to decouple your code. Actually, you don't want to decouple your code. If you decoupled your code, the code wouldn't do anything. You want loosely coupled. If your code was completely decoupled, then all your classes couldn't communicate with each other. But basically, like as I think I mentioned in the webinar, like Kinesins of Name and Kinesins of Type are actually desirable. You want a name that you can use in one place and another, and you want the types to match up in both places where they're declared and used. So that kind of coupling is okay. But then that's considered loose coupling, and loose coupling is good, and tight coupling would be coupling where the kinesins are higher in the taxonomy, and that was bad. And you want to, I guess the word you would use is decouple the code to make it more loosely coupled. How's that? And I don't have an ISBN for the book yet, but you will keep an eye on my blog, and I'll certainly make noise about it because I want you to buy it.
Excellent. All right, guys. Well, thank you very much, Nick. Been a very, very interesting, informative webinar. Great that we've had so much good positive feedback on this as well. Thank you, everybody, for your questions. Without that, then we'd be sitting here having a really boring Q&A session. So, as always, great for some really, really good questions and to be able to take those through. Thanks very much for joining us. Happy coding to everybody, and we'll see you next time through.
Thank you very much. Thanks for the kind words, and thanks for attending.
Talk to everybody later. I just put the link in for the where the replay and stuff will be. It's on the community site, and we'll get those uploaded soon.
Nice.
Great. Okay then, guys. Thanks very much, everyone. Bye-bye.
Bye.
Bye-bye.